Hello all of my wonderful Algebra 2 trig students. This is Mr. Longo, and this video is going to cover your review for Unit 1 for your final exam. And I may not do every single question in each section if it's a very easy section, but if it deserves me talking about it, I will make sure that I do so. At some point you will also have an answer key to the entire packet online as well. So if this doesn't cover every question that you have, don't worry, that'll be coming soon. Okay, so the first three questions deal with an axis of symmetry and a given point, and you're supposed to state one other point that must be on the parabola. Okay, these are very simple. The only thing you have to do is remember that an axis of symmetry means it splits the parabola in half symmetrically. So if we are given that our axis of symmetry is x equals 0, and one of our points on our parabola is 2, 8, then that point is 2 units to the right of your axis of symmetry. There's going to be another one at the exact same height, 2 units to the left of your axis of symmetry. So another point that is guaranteed to be on that parabola is a -2, 8, just because we had to go 2 units to the other side. Now, it's extremely simple to do that when we have an axis of symmetry of x equals 0, but what do we do when we have an axis of symmetry for x equals 3? The exact same thing. We're going to plot -3, 2, so let's think about where we're at. This is 3, so we need to go back to 2, 1, 0, -1, -2, -3, 2. So that was 1, 2, 3, 4, 5, 6 units to the left of our axis of symmetry. So let's go 6 units to the right. So we are 1, 2, 3, 4, 5, 6. So 6 units to the right of 3 would be 9, 2. The height will not change. It's going to be symmetrical. Remember what a parabola looks like. It would be something like this. For that example, and over here, it would just be a little bit wider. It would be something like this. Now, again, we don't even know if that parabola is opening up or down because that's not even part of it. We're not really concerned about that. I just wanted to remind you what an axis of symmetry does, okay? You would do that for the next problem as well. You would do it the exact same way. And for an answer, you would end up getting -11, -5 once you go through the work, okay? The next section is factoring. Now, obviously, factoring is hugely important. The next 2 sections are actually factoring. So, remember, when you write a quadratic in intercept form, that's also factored form. Okay, so these next 2 sections are all based on factoring. So let's talk about it. Number 4. That's just a factoring question where we ask what multiplies to a +6 but adds to a -5. That's extremely simple. We just say x minus 2 and x minus 3. And again, there's always ways you can check your work. You can FOIL that if you want to. Or you can type this into y1 of your calculator. You can type this into y2 of your calculator and check the graph or tables and make sure that they are identical. You have x squared plus 81. Now, they're both perfect squares, but that says plus, and that is not what we're looking for here. So this one is prime. Remember, you can only work with perfect squares if there's a minus sign in between them, like number 6, because we can work with what's known as the difference of 2 squares. Now, this one's just set up differently for just thinking what your values of a, b, c, and d would be, to show you that we have sometimes questions where you have to just think one step further. But the square root of 4x squared is 2x. So we're going to write that there twice. And the square root of 9 is 3. But we're going to have a +3 and a -3 because we need to multiply to a -9. That only works with a +3 and a -3. And again, we can only do that when we are working with the difference of 2 squares. But once in a while, we'll have weird questions where we're just listing our coefficients. So the coefficient of a and c is both 2, but we have a b, which is a +3, and we have d, which is a -3. But again, it's just the same thing. We're just factoring. In the next section, as mentioned, we're still factoring. We're just going to write our answers in intercept form, which means we're writing an equation. Keep in mind, we're writing an equation. So to factor this, we're just looking for what multiplies to a negative 20, but adds to 8. And that would be a positive 10 and a negative 2. So we're going to have x plus 10 and x minus 2. But you cannot forget about the y equals in front. That is telling you that it is an equation in intercept form. If you don't have the y equals, it's just an expression. But then to list our intercepts, remember it's opposite. So this would be a negative 10, 0, and a positive 2, 0. Okay? The next example is splitting the middle term. That's where you multiply the 2 and the 3, and we get a 6x squared. And now we're asking what multiplies to a 6x squared but adds to a 5x. That would be a 2x and a 3x. And that's the whole part where you just split that middle term. And this is where you also have to remember to bring down the first term and bring down the last term. So all we did was split that 5x to a 2x and a 3x. And then you just use grouping. So we factor out our GCF of this one, which would be 2x, leaving us with an x plus 1. We factor out the GCF of the second set, which is a 3, leaving us with an x plus 1. Remember, you are only correct if the inside is the same. If it is, we can write that down once. And then we take our GCFs of each set and we create our own. So that becomes a 2x plus 3. Do not forget the y equals in front. And our intercepts would then be a negative 1, 0, and a negative 3 halves, 0. Remember, all we do is set that equal to 0 and solve. The last example is another example of difference of two squares because we have two perfect squares. So this is going to be y equals an x minus 3 and an x plus 3, leaving us with intercepts of a positive 3, 0, and a negative 3, 0. Okay? So that wraps up the factoring sections for this review. We're going to move on now to what we call completing the square. Now this was a little bit different. There are different ways to do this, but remember the way I taught you guys in class is the first thing you should do is x squared plus 4x, and you leave some space, and you have to move your constant over to the other side first, no matter what you do. Even in this next example, we have 3x squared minus 6x. We're going to leave a little space equals a negative 4. And going back to this one, you need two spaces. And what you have to do is you take half of this value and square it. So half of 4 is 2, squared is 4. And you write that down on that line, and we're going to write it down on this line. And then all we have to do is say what would factor to 4 and 4, and it's going to be x plus 2 and x plus 2. But remember, the shortcut was we take parentheses, x and half of your b value. So half of a positive 4 is a positive 2. Quantity squared equals 10. Now remember, to write an equation in vertex form, we just move that 10 back to the other side. So we have y is equal to x plus 2 quantity squared minus 10. And then you have to remember that the vertex is going to be opposite of the inside comma outside. So we would have a negative 2 comma negative 10. Okay? So that's how we write an equation in vertex form, by completing the square. But when we have a number in front, a leading coefficient, that makes things a little bit more challenging, because we must factor it out before we do anything else. So we're going to factor out a 3, leaving us with an x squared minus 2x. Leave some space, close our parentheses, is equal to a negative 4, and we have to add something to that side as well. So half of 2 is 1, 1 squared is 1. But on the left side, notice we have a multiplier of 3. So we have to multiply that to that 1 before we add it to the other side. So that's going to be adding 3 to the right side. So We have a 3. X, half of a negative 2 is a negative 1. Quantity squared is equal to a negative 1. Bring that negative 1 back over, and we have y is equal to an x minus 1 squared plus 1, leaving us with a vertex of a positive 1 comma positive 1 because we have to take the opposite. Last example, half x plus 6. Okay, so that's x squared plus 6x plus, we have to leave a little bit of space, is equal to the negative 7. Now, I want you to remember, this is division. When you factor something out, that is division. What is 3 divided by 1/2? Remember, when you divide by a fraction, it's like multiplying by the reciprocal. If you're not sure, go type it in your calculator. But think about it. If this was 3 divided by 2, you would say 3/2. So how can 3 divided by 1/2 also be 3/2? Got to be very careful with that. Okay, half of 3, or half of 6 is 3, squared is 9, and we need to multiply 9 by 1/2 to multiply or to add it to the other side, and that's 9/2. We just have 1/2, and then we have our x plus half of 6 is 3, squared is equal to 9/2 and a negative 7 come to negative 5/2. Finally, we have y is equal to 1/2 of x plus 3 squared, and bring that back over to the other side, plus 5/2, and that gives us a vertex of a negative 3 comma positive 5/2. Okay, so that is how you complete the square to write an equation in vertex form. We only have a couple questions left on Unit 1. And a lot of it comes from, how do you know, based on given equations, what your vertex axis of symmetry, x-intercepts, and y-intercepts are? Now, these come from the 3 different forms of a quadratic, and they each have their own special powers. Remember, this one right here is called standard form. This one over here is intercept form. And this one over here is vertex form. Now, we just talked about all 3 on the other side in a way, but we did things differently. But if you were given all 3, how would you be able to pick out the vertex, the axis of symmetry, x-intercepts, and y-intercepts, all from looking at these equations? And the answer to that's pretty simple. Vertex form we just talked about. It's opposite of the inside comma outside. So that's going to be a negative 4 comma negative 4. And you would just explain that it comes from vertex form, opposite of what's inside the parentheses, comma, what's outside. And remember, your axis of symmetry is x equals a negative 4. Your explanation is just your axis of symmetry is always the x equals the x-coordinate of your vertex, because it must pass through the vertex. Our x-intercepts come from intercept form. Again, we just talked about this. So you would just set each one of these equal to 0 and solve, and you would get negative 6 comma 0 and a negative 2 comma 0. Do not forget, when you're writing intercepts, they are coordinates of points. We don't say negative 6 comma negative 2. That's wrong. We have to list the intercept. Finally, the y-intercept comes from standard form. It's the last value, c. It's always 0 comma your c value, which is 12. Okay? Now, the last 2 questions of this packet are done with your graphing calculator. Now, we're not going to go type things in the calculator right now. That's a skill that you need to have. We're going to talk about it, though. So this is what you're going to need to do. You're going to need to type this equation into y1. And do not forget y2, you want to leave a 0. And what you need to do next is discuss your window. Now, we're talking about Babe Ruth hitting a home run. If he's going to hit a home run, he's obviously not going to hit it backwards. So you need an x minimum of 0. Or you can do a negative 1, it doesn't matter. But you don't need to do negative 10. You also need a y minimum of 0 or a -1, -2 if you want to see the graph. But the reason why is because we're not going to hit the ball underground either. So it says that the fence is 325 feet away, and we're going to check to see if he hits a home run. So that's the minimum distance he needs to hit a home run. And so let's just go with an X max of 350. And then your Y max, it's kind of hard to tell. We don't really know how high he's going to hit the ball yet based on that equation, but we do know he's got to hit it at least 350. So there's a pretty good chance he's going to hit the ball pretty high as well. So why don't we just call an X max of 200? Okay, that is extremely important that you know how to create a window. Okay, so we're going to pause right there, and I will get the graphing calculator for you so you can see what it is you need to type. All right, that should make things a little bit easier for you. So this is what our graph looks like. And we need to label our important points, but in order to do that, we should probably go find them first. So we're going to need a maximum. We're going to need to find out how far the ball traveled, so that would be our x-intercept. And we also need to determine, does he actually hit a home run? So let's talk about those keystrokes again. To find a maximum, you need to press second, trace. And number 4 is maximum. And it's going to ask you to do a left-bound, right-bound guess. So once you're at the maximum point, you need to just kind of back up to the left a little bit. Click enter. And then you need to go to the right of it a little bit. Click enter again. And then you want to go to guess. Click enter one more time. And it looks like it gives us 170, 115.6. So that would be our point, 170, 115.6. Now, what does that mean? Well, if we're asking for the maximum height of the ball, the answer is 115.6 feet. Because the height would be our Y value, not our X value. At that time, it's 170 feet from home plate. Still got a while to go. How far does it travel? To do that, we need to find this x-intercept over here. To do that, you press second, calc, and then you just need number 5, intersect. And we're just going to scroll and scroll and scroll. But to be honest with you, as long as you're closer to that one than the other one, you can just go ahead and guess 3 times. And you get 340, 0. So this point is 340, 0. So how far does it travel? 340 feet. But the real question is does he hit the ball over the fence? Does Babe Ruth actually hit a home run? And to do that, you need to go right here to the fence distance of 325 feet. And we need to see if it's high enough. So if we go to 325 feet, there's a couple of ways you can do that. You can just straight up type 325 into the equation. So you can do negative 0.004 parentheses 325 squared plus 1.36 times 325. You can do that. Or you can go check it out on the table. So to do that, we press second table. And you could, if you want, click down 325 times. Or you can remember, just like we change our window, we can change our table. So if you click second window, that modifies the table. This is telling us that it's going up by 1, but this right here is telling us that we're starting at a -2. Just type in a 325, click second table, and now you're starting at 325. So either way you look at it, you're going to be at 19.5 feet. So the question is, does he hit a home run? Does he hit the ball over the fence? And the answer is most definitely yes. To explain, you would just say at 325 feet, the ball is 19.5 feet off the ground, which is definitely higher than 7 feet. something along those lines. Okay? And there's one more example of a word problem here where we're talking about the exact same thing. It's just that now it's Roy McIlroy that's out golfing, and he has a tree that's in front of him that's 45 feet tall. He's 60 feet from that tree. Can he hit the ball over the tree if his ball is modeled by the function negative 1 over 400 x times x minus 300? So let's go check. We're going to clear this guy here. Now, notice it didn't ask us for the maximum height. It didn't ask us for how far the ball traveled. All we're doing is figuring out if he can hit the ball over the tree. So let's type in, for those of you that did not know, if you have one of the newer calculators and you click alpha y equals number 1, you can change that to a fraction. So you can type your negative 1 over 400 if you were not sure about that. But anyway, slide out, and we then have x parentheses x minus 300. So obviously, if you're thinking, you know he's going to hit this ball 300 feet. But we're not wondering about that. We're wondering if he hits the ball over the tree that's 60 feet tall, or 45 feet tall, that's 60 feet in front of him. So you can click and look at the graph if you want to. But we just need to look at the table. Now remember, our table's at 325. The tree is 45 feet tall and is 60 feet in front of him. So we just need to go to 60. And you can click second table again, and we will see at 60 he is at 36 feet. So we have 60, comma, 36. Again, you could have just gone straight to the calculator and typed it in that way as well. Negative 1 divided by 400. And then type in 60 for x. And then type in again 60 for x. Click enter. Wow, we get the same thing. So when we're testing a certain point, you can just plug it into x. Either way. And you'll notice that he's 36 feet above the ground at 60 feet. So the answer to this one is no. And all you need to do is say that he will hit the tree because it's only 36 feet off the ground when he needs to hit the ball over a 45-foot tall tree. Something like that. All right, y'all. That's it for this video covering Unit 1 of your final exam review packet. This is Longo, and I'm out. See you, bye.